Sebastián Palacios, and today we're gonna be using an ultrasonic sensor, a servo, and a buzzer to better my reverse parking skills. Since my car is a little bit old, I don't have any sensors or a backup camera that I can use whenever I need to go backwards. So I need some sort of system that tells me to stop whenever I'm getting too close to something. So this is where my project comes in. The necessary materials for this project are going to be red and green LEDs, 3 220 ohm resistors, some jumper cables, a 9-gram 180-degree servo motor, you can use any, it's not just 180, a buzzer, an arduino uno, a power bank, an ultrasonic sensor, a breadboard, and of course a computer with arduino programming. So the system is pretty easy to understand. First, there's going to be an output from the trigger pin, remember, from the ultrasonic sensor. Then there's going to be an input from the echo pin, so that one's going to receive the sounds that come from the ultrasonic sensor. Then we're going to obtain the time it took, and with that time, we use the speed of sound to calculate for the distance. Now, if we know how much distance there is, we can separate it. If this distance is more than 60 centimeters, then there's going to be a green light, the red light's going to turn off, there's nothing happening, except you're going to be able to continue. Now, if it's closer than 60 centimeters, then the red light's going to turn on and the green light is going to turn off. The buzzer, the one that makes the sound, is going to turn on, and the servo is going to move to 90 degrees instead of going to 0. See? This is going to be the one that's going to alert us if we're getting too close to something, because that's easier for me to see from the driver's view. So the circuit diagram for this project is going to be this one. You're going to output your voltage from the 5-volt on the Arduino, as always. And then it's going to go in just 2 ways. One of them is going to be directed to the ultrasonic sensor in the positive, or marked as VCC. The other one is going to go to the positive port of the servo. The ultrasonic sensor is going to be also connected to the pin outputs. They can also be inputs, but we're going to see that later. D13 is going to be connected to trigger, and D12 is going to go to echo. Continuing with this ultrasonic sensor, the ground, you can guess where that goes, of course, to the ground. The servo is pretty much the same. It goes from D9 to pulse. We already know from one of my previous videos that pulse is the one that's going to be deciding how much this servo is going to position itself. Negative, also, you have to ground it. Next comes the green LED. That one is going to be connected to D7, and also it's going to have a resistance of 220 ohms, and then grounded. Second, the red LED, that one also has a 220 ohm connected, and then D2, which is now connected to also a 220 ohm, but then it goes to the positive part of a buzzer, and then the negative goes to the ground as well. Excuse those sepia pictures, it's my sister's desk. We're going to first connect the Arduino 5-volt and ground to the breadboard. Next, there comes the ultrasonic sensor, which is also going to be connected to the voltage. Ground to the left row, and voltage to the right one. Next, we're going to connect echo to pin port number 12 in the Arduino. Next, we're going to connect trigger to pin port number 13. Next, connect pin port number 7 with the resistor and the green LED. Next, pin port number 6, resistor and red LED. They are connected to the ground. Next, pin port number 2, and in the same row, you're going to put the resistor and the buzzer. The buzzer is also grounded. And finally, we're going to connect the servo to number 9, pin port number 9, grounded, and then connect to the positive. And there you go, that's it. So how the programming works is, first, every variable is declared, as well as which action is attached to what number and the inclusion of the servo from the library. Then, for void setup, 0 begin is declared to be 960. This is standard stuff. And every component is attached to pin mode, all of them being outputs except for echo, which will receive the ultrasonic sound from trigger. The servo is also positioned to be 0 degrees. See? In void loop, trigger pin is turned on and then off after 10 milliseconds. At the same time, echo pin is activated to measure the duration it takes for the sound to go and come back from the object. This data is then put into an equation to first divide into 2 parts, taking into account only one of the trips of the sound, because it goes and it comes back, and it's like the same distance, so you just need one of the trips. As well as converting this time into distance by multiplying it to the speed of sound. After that, There are conditions. If the distance is more than 60 centimeters, then the green LED will turn on, the red will turn off, buzzer will turn off, and the servo will be positioned at 0 degrees. So, kind of like if nothing happens. Else, meaning that there is less than 60 centimeters of distance, the green LED will turn off, the red one will turn on, the buzzer will also turn on and create a frequency of any amount you like for 50 milliseconds, and the servo will position itself at 90 degrees from the starting position. So now it's going to be pointing at something else. So that's going to be the signal for me to stop. The following program is just necessary to measure distance with serial monitor. You can put it on your code or not. Now that we finished, we're going to try it. So I will show you Sebastian from a couple hours ago.
So now I installed it into my car. As you can see, here's the breadboard and the Arduino. We're gonna be connecting it to a power bank because we want it to be rechargeable and use it again some other time. Here's the servo, and inside we have stop and go. We're now gonna connect it and test it with the other car. Yes. Now, here's my point of view. From this side, we're gonna start reversing, and you're gonna see when it's time to stop.
Lol.
If I get out of the car when it says stop, you can see this is a very good distance, and you can also hear the buzzer buzzing. If we go forward, you can see that it goes back to continue, so I could continue reversing. That's it. That has been the project. Thank you a lot for watching, and I'll see you again with another project sometime soon, I hope.